So I was thinking about what I want you guys to take away from Algebra 1. Hopefully what I can present you with that's going to make it easy for you to succeed. And so if you learn anything in this class, it's that you can find patterns within these groups of numbers. In English, or in any language, there's three ways of symbolizing something. If you have an elephant, you could put the word with the letters. You read that, and you know that's an elephant, right? You can hear the sound, elephant, without seeing the word, and you know that that's that animal, right? And the only other way that I could think of is if you actually see a picture of an elephant. You don't have to hear the word. You don't have to see the word. You know what we're talking about. And so at the very beginning of the year, we were looking at functions, not elephants. And we could represent a function with tables, which is what you guys did in part 1, looking at the tables. You can represent a function as a story, like this. We were playing with curves last week, right? You can represent a function as a curve and also as an equation. You guys are going to be coming up with an equation in this one. And so being able to switch back and forth between all of those modes of understanding patterns, because that's all a function is. We input something, it does the same thing. A pattern is a repeated thing, and it outputs a different answer. So as we're moving forward, I'm hoping to make connections back to seeing functions in one of those ways. The more you can do that, the more you can see a graph or an equation, a story or a table, and understand the pattern, the more successful you're going to be in this class and beyond this class. So delta math, it says at the very top. We're going to get into that in a second after we do our couple examples here. And it's going to tell you to come up, you need to actually come up with an answer. We're given a car in this case, and we want to know after 8 years what that car is worth. So again, we start off with the starting point. We could give this function a name. Let's not be fancy about it. Let's just say f of something. We're looking at time. So let's say f of t. And the y-intercept, or that starting point, what number is our starting point for this car? 16.00. That's how much it costs, I'm assuming brand new, or at least when this guy bought it. And then it depreciates by 12.5%. What do we have to do with that percent right away? Take that and divide by 100 underneath of it. It's going to have the effect of exactly shifting your decimal place 2 points. We don't need a placeholder this time. I'm going to put a 0 in front, but it's just going to be 0.125. Our decimal used to be right here. We divided by 100, so we made it smaller by shifting it the same number of spaces as we have zeros. We're definitely going to use that in a second here. First, we got to plug a 1 in. Are we going to be adding that number that we just came up with, or subtracting? It depreciates, right? Meaning it goes down. So let's subtract 0.125. And again, if you end up with a really cheap car at the end of this, you know you forgot to divide by 100, because if you start with 1 and take away 12 from it, I don't even think we can have a negative number in there, right? It's just too big of a number. If this was increasing, we would be multiplying it by 12 each time. Our car would get really pricey way too fast. What am I missing? What's the one thing I'm missing on my equation? Exponent. This is an exponential equation, so it needs an exponent. Let's go ahead and do the in-between step of solving what's inside the parentheses. So we can just copy our 16,400, and we're going to multiply it times. If you have 1 and you take away 0.125 from it, it's a little bit more than taking away just 0.1, so it's going to start with a 0.8, 0.8. Otherwise, you would have like a multiplication and then a decimal. That gets complicated. 0.8 what? 875, that sounds right. Raised to the t power, and I'm actually going to change that t. What should I change the t to? What's our value of time after how many years? We want to know after 8 years what that car is worth, right? So we're going to plug in 8 as the exponent. You can plug this into your calculator. Of course, you'd do exponents first. If you're doing it on your own, you would multiply 0.875 to the 8th power and then multiply it times 16,400. Or in your calculator, 16,400 times that risen to the 8th. So having that button there. You guys know where that button is on your calculator? It's on the right-hand side. Yeah, it's above your other operations, which this is an operation, so it would make sense that it's above your other operations. What is when we plug in that, what is the calculator saying your car is worth? That's if you did this part. I think it turns into 0.3 something. Then make sure and multiply it by this. I think if you did this part first on your calculator, if you just push the multiplication button and 16,400, then it'll take your previous answer. It'll say ANS times this new number.
Times it by 16,000.
16,400. Multiply it.
5,300, 5,600, 635.
And it says to the nearest cent, so give me 3 places behind the decimal. You got 3 places behind the decimal? All right, 1, 8, and 6. Since it's a 6, let's round it up to 1, 9, which would be closer to 19 cents would be closer to 18.6 cents than 18 would. So you round up. And does that sound reasonable? If you paid $16,000 for a car after 8 years? And there's a few things it depends on, how many miles you put on, all that kind of stuff. But in general, there is this pattern. We can use this function, plug in, and find out how much it's worth after so many years. Let's go ahead and do number 2 together. What's our starting point? And again, I think we're talking about years, so let's say f, a function of time, f of t. And yes, we're starting with, and I didn't even check what we're doing here. Annual interest rate of $8, that's pretty good, or 8%. How much will be in the account after 24 years? So we know that it's going to be multiplied by 1 plus or minus something. Should we say 1 plus something or 1 minus something?
1 plus.
Yeah, so this is an account. It doesn't say a loan. So an account where we put money in, this amount, and it's going to grow. So let's put a plus. And if we said, and just put our 8 in here, then we'd be multiplying by 9 right away. I don't know what 6,000 times 9 is, but that's unreal. You cannot make money like that. So what do we do with the 8?
Divided by 10. All right. 0.08.
And yes, 0.08. Make sure that there is a 0 between the decimal and the 8. 8% is 8/100ths, and here it is in the 100th place. If we were to put the 8 here, that would mean 8/10ths, right? We're talking about 8/100ths. And what should we raise all of that to?
24.
Yeah, it's going to stay in there for 24 years. So let's go ahead, and you can start off by typing 6,700 into your calculator, and then say times, and when it's addition, it's super easy. What is 1 plus 0.08?
1.08.
Exactly, 1.08. And then type that caret top button on your calculator and put a 24, and that should tell us how much money we've made, letting that money just sit there for 24 years. Anybody come up with an answer? Did you get an answer?
42,485.
So, and I typed it into Google, and even Google knows order of operations. I didn't put any parentheses around anything, but it used to take that 1.08 and rise it to the 24th power, and only then multiply by the 6,700, and that would give us 42,485, 91 cents with a 0 behind it, so we'll keep it rounded down to 91. That's a really unreal interest rate. If you find an 8%, then definitely put your money in there, because if you just let it sit, you went from almost 7,000 to how many sevens would fit into 42? 6. You got 6 times your money. So go ahead and at this time, go ahead and open up your Chromebooks and type in deltamath.com. You can sign in through Google. Keep your notes next to it here, right? Because these notes are going to help you out with your the problems in Delta Math.